Hello and welcome to Altitude. Today we'll be talking about what nature can teach aviation in the aptly named Project Geese. I'm your host, Russell Porter, and today I'm joined by Laura Montironi from Airbus, Captain Kevin May from Delta, and NATS' very own Andreas Petrikat. Laura, Kevin, Andreas, welcome to Altitude.
Thank you.
Good to be here.
It's great to have you on the show. We'll be focusing on formation flying, looking at progress on Project Geese, and we'll be taking a little bit of a look ahead at what the future might hold. As ever, we're live, so do place any questions that you might have into the chat. With that said, Laura, would you like to make an introduction, please?
Sure. Hello, everyone. So happy to be here with you today. So I'm Laura Montironi. I'm working for Airbus in Toulouse, in the Toulouse site. I am in a team working on system development and ATM concepts. And in particular, why I'm here today with you is because I am coordinating the Geese project.
Laura, great to have you on the show. Kevin, would you like to say hello, please?
Sure. Yes, it's a pleasure to be here. I am an Airbus A350 captain and lead line check pilot with Delta Airlines. Had the pleasure of flying Airbuses for almost 30 years now. And in my role in the flight standards department, I train other pilots, evaluate pilots, and then also work on special projects such as this one.
Thanks very much, Kevin. Great to have you on the show. And Andreas.
Hello, everybody. I'm Andreas Petrikat. I am working in a NATS R&D department. Coming back from a background of aerospace engineering and aeroacoustics, I've worked here first on optimized separation concepts, which is a little bit apropos to what Geese is doing, even though a little bit different. In Geese, I'm acting as the technical lead on all the ATC aspects that wake energy retrieval as a concept has. Very happy to be here.
Great stuff. Thank you, Andreas. Welcome to Altitude. Andreas, you gave me the perfect segue for perhaps our first question for Laura. You spoke about wake energy retrieval there. Laura, aviation does love an acronym. Can you help us out with what WER stands for?
Sure. So the idea is to fly one aircraft. We will call it follower. Behind another aircraft, we call it leader. And in this way, with a reduced separation, longitudinal separation with respect to nowadays operations, the follower aircraft will feel a smooth updraft generated by the wake of the leader aircraft. And this allows him to reduce the engine thrust, which means reducing fuel consumption, of course, and the associated emissions.
Thanks, Laura. The project is appropriately named Geese. One of my favorite words has come up in the prep for this, biomimicry. Can you tell us a little bit about how the concept, what it learns from the formation flying of Geese?
Yeah, so the two aircraft are not exactly aligned. They are more or less in a formation. So it's a sort of reduced V-shape formation. So this is what we see when geese or migratory birds in general are flying and migrating across oceans and continents. So, of course, they do it with a lot of different elements. We will do it with two for now. And yeah, this is the idea.
And this is a César project. And tell me how that fits in with Airbus's Fellow Fly program.
Yeah, so here in Airbus, we have started studying the concept years ago now, mainly concentrating on as a first step on the technology on board. So what we need to put on the aircraft to allow these kind of operations. After let's say the demonstrator phase of the Fellow Fly project, which was concluded in 2021, we continued working on the aircraft system development side, of course. And in the meantime, we understood quickly that we needed to start working with all the ecosystem around the aircraft, so air traffic controllers, but also with the user of the aircraft, so with flight crews and with airlines in general. So this is why Geese is existing, so to support the Fellow Fly initiative, working with the ecosystem and to prepare all what we need to have around the aircraft to make it possible.
Thank you, Laura. So speaking of airlines, Kevin, you flew, I understand, an A350 in the trial. Would you like to give us a bit of a flight deck perspective on what that was like?
Sure. And just as a little bit of background, I obviously have been involved with the lead up to this for at least the last year and a half, and all that went into getting us to the flight trials. And the flight trials were kind of, I call it, everybody in the orchestra all singing at the same time off the same sheet of music. So we got the opportunity to do that in September and October last year. And it was just a very exciting opportunity for us to participate in real time and look at all that we had done in terms of like tabletop exercises and, different evaluations. And I should say also prior to that last summer, the team came to Atlanta and worked with our dispatchers to get them all integrated and trained. And so now we're all working together. And from a flying perspective, quite honestly, the flight portion of it is normal operations. It's what we do every day. But we were now doing it with a specific purpose in mind. And Andreas can speak to this a little bit more too about the air traffic control when we get into that. But really what we were doing, and this is the beautiful part of it from a pilot's perspective, is operationally, at least at this phase, there's nothing really different that we're doing that we aren't already normally trained to do and would do in a normal daily operation.
Nice. Thank you, Kevin. Andreas, Kevin spoke there about the orchestra that's required to bring all of this together. Can you talk about the coordination that was required to deliver the flights to the same point?
Yeah, absolutely. I mean, I have to say, with these flight trials and with Geese in general, I think it's a beautiful piece which demonstrates really CESAR at its best, really bringing all of the stakeholders in aviation together for one shared purpose. Now, for the flight trials specifically, I really want to give a lot of credit to Airbus for bringing us together, for managing this, for aligning us on a common ConOps and a common goal. With that, really, we could then start the process of going through the safety assessments on all sides. I mean, there's a lot of paperwork for good reason to be made if you're doing something like this in live operations. Kevin can speak to the airline side now. On the air traffic control side, I can say how we engage with operations experts, with our safety team, and of course the CAA to really make sure that there wouldn't be any hazards introduced by these trials. Before we then went and disseminated the instructions to our ops experts, to our ops staff, actually, so that then on the day it would all go smoothly. And it went actually in several steps. So at the start, we had a go, no-go call where we would get a first idea on like how the trajectory change might actually look like. With that, we could already make some kind of preliminary assessment whether there'd be any problems in operation that would prevent the trial from going ahead. After that, we would basically monitor the situation as the aircraft would get loaded, passengers would enter, and they would do their pre-checks. And everybody was just waiting almost impatiently to the point when then the call-out would happen on the ground by Airbus using their pairing assistance tool to really determine, okay, what is the exact trajectory change that would bring those two aircraft together. On our side, the clock would then start ticking to go into the ops room, ask our operations supervisors if it would all be okay to go ahead. Once we had been given the green light there, we would then go back outside and let our partners know that it's okay now to proceed with this request to change the trajectory. All eyes would then swivel over to our press wake operations, where our clearance delivery officers would listen on the radio, waiting for the aircraft to call in and confirm that, yes, they can do this rendezvous. And at that point, we could then advise the aircraft to start setting their required timely arrival function and are actually arriving at the rendezvous point at the same time. And after that, basically, it was left to us to, I want to say, more or less enjoy seeing those aircraft converge together. And we actually do have some pictures on this, which I have to give credit to Air Nav Ireland to capture that of radar screen. So what we do see here, basically, from an operational system is two aircraft with long radar vectors converging in this triangle towards a common point. So at the top, we have the Delta 73 flight, which would be with Kevin on board. And on the top, we've got the Virgin 3 November converging together. Now, one thing to really point out is here, although it seems like they're on a collision course, they're very much not, because they're on different flight levels, right? The air traffic controller can see here, okay, right, they're still on flight level 370 and flight level 380, so that's 1,000 foot between them, which is a perfectly acceptable separation in current operations. And then if we move to the next image, we can then see basically how it actually worked, and these two aircraft, which have taken off of airports hundreds of miles apart, they actually managed to get together with a lateral separation of just 1.1 nautical mile, which is pretty much as close as you can get to a perfect rendezvous. So if these aircraft then had the tools that Airbus is now developing on board, they could then, using very little additional energy, actually go into formation and start harvesting that energy. So really an amazing result, I think, for something where a lot of work is needs to be done and a lot of variation can happen.
Thank you, Andreas. Kevin, nice to see your work as well there, your flown aircraft on the screen. In terms of flight planning and consideration of the wider Delta operation, how did this come together? What was the difference for you?
The difference really, I mean, we're talking about a route change is the terminology we use, trajectory change. And this is a process that we do fairly commonly in the aircraft. But in these particular cases, as Andreas pointed out, we had calls early before the flight departed, and we were talking, we had our dispatchers on the line, the dispatchers from Virgin, as well as Airbus and Andreas and other stakeholders. And we were all talking about, like he said, what are the different things that all have to align in order for this to happen? What I also wanted to point out was that route change and the aircraft converging on a particular point at the same time. This actually happens every day. I mean, this is not anything out of the ordinary in those oceanic entry points going across the Atlantic. You often have aircraft that end up right at that same point at a very close to the same time. What was different about this was we were doing it intentionally and with a specific aircraft rather than just randomly showing up there and there happened to be another airplane above or below us. So what went into that, of course, was, and Laura can probably talk more about this too, about the pairing assistance tool and all that does to then provide information to the air traffic controllers that are involved and to our dispatchers. They're doing a lot of the behind the scenes work initially to determine whether or not it's even feasible today. Once they all make that decision, we're already airborne. And once we're airborne, they will then send that information up to us. And then we get what Andreas referred to as a pairing call out. And the pairing call out just says, okay, here's the proposed trajectory change and the times that must be met in order to do that. And we look at it and then we do our assessment, and safety is always going to be number one. So we're going to keep that in mind. And in this particular case, I'll add that I was a third pilot. We had our regular pilots that were flying. I was in the observer seat and I was basically overseeing and collecting the data and just facilitating this so that they could focus on flying the aircraft, which is their primary job. And then we look at it and we all agree, okay, this looks good. We can safely do this. This isn't anything out of the ordinary. And then, as he said, we go to the next steps of coordinating it with the air traffic controllers. And if their traffic permits, we go ahead and take the route change, which in that case of the display that you showed a little while ago, that happened to be one of our flight trials, and everything just worked beautifully. So all the planning that went into it, that was all behind the scenes. We were kind of last ones in line to just look at it, do our assessment and say, yep, this looks good to us. We're comfortable with this, and we do it.
Thank you, Kevin. So Laura, a couple of technical constructs have come in there. So there was a term energy harvesting. Definitely want to understand more about that, because that sounds like it perhaps is at the crux of the big benefit of this whole thing. And also a concept or a tool, the pairing assistance tool. So could you perhaps unpack those for us, please? Thank you.
Yeah, so with the terminology energy harvesting, I think Andreas was, yes, meaning that once you, so okay, to be clear, in the flight trials, we only cover the procedure to get the two aircraft on the same, separated vertically, but on the same geographical coordinate, right? But if the aircraft were Airbus aircraft equipped, so future Airbus aircraft, then that will be the first starting point to start flying really in formation. So to close the separation between the aircraft and to allow the follower aircraft to save energy surfing the vortex of the leader aircraft. So this is the, let's say, energy harvesting phase, which was not, of course, covered by the flight trials, because flight trials were done with nowadays aircraft without this capability on board.
Thank you, Laura.
And about
the pairing assistance tool?
Yeah. So the feasibility of reaching the same geographical coordinate more or less at the same time for two flights depends a lot on the timing of the takeoff of these two aircrafts, right? So, and we don't have the full control of this takeoff time, so we have still always estimates, but there is still some shift, anticipation or delays on the takeoff time of flights. So this is why the concept, once fully deployed in real operations, will rely on this pairing assistance tool, which is a centralized tool computing using real-time flight data, traffic data, which are the pairs, which are the flights who could meet and could start saving fuel thanks to the flight rerouting and so on. So for the flight trials, of course, we needed to know in advance which flights were doing this, because we wanted to have Kevin on board and we wanted to have the informed controller on ground and so on. So we had this limitation, let's say. But yes, in the real operation, this will be decided fully. So really after the takeoff.
So it becomes quite a tactical thing within the operation then.
Yeah, pretty tactical, you can say. Yeah.
And with that in mind, given that there are numerous variants and aircraft types out there, how closely matched do the pairs need to be in terms of aircraft types to see the benefits?
So what is important is the compatibility in speed and altitude. So the idea is that these two aircraft will fly at the same speed and the same altitude for a long time together. So of course we need to have to do this with aircraft which are having this speed and altitude compatibility. So optimized speed and altitude compatibility. So this is the main requirement. Yeah.
Okay. Now, if we were to see this scale up and rolled out across as many flights pairings as possible across the Atlantic, just how big could the benefit be in terms of fuel and CO2 savings?
So on one only cross-Atlantic flight, so per flight, the saving is around, so in average is 2 tons of fuel. This was also demonstrated in flight in 2021 with flight test aircraft, of course. So if we consider these apply to the whole traffic flow over North Atlantic Ocean, this will make something like 150 kilo, so 150,000 tons of fuel per year, which is enormous, of course. But of course, we cannot expect all the flights will do this operation, right? So the percentage of how many flights will do it depends on how many aircraft will be equipped and so on. So it will be for sure a ramp up, let's say, over time. But yeah, it is even if only 50% of the flights will do it, it's already enormous.
Yeah, that's a huge benefit. And you talked about the fact that during the trial, the aircraft didn't enter into the energy harvesting process. Just how close do they need to be in order to do that? And these are my imaginary flights, apologies.
Yeah, no problem. So in order to really save energy between leader and follower, there should be a longitudinal distance of 1.2 more or less nautical miles. More or less, it is an average, let's say. So it will be yes, move around this distance.
Okay, Kevin, thank you, Laura. So coming to you, there are lots of airlines that cross the Atlantic. Will the concept only apply to aircraft flown by the same airline, or might we see different airlines in formation together?
That's a great question. And in fact, in the flight trials, we actually, as you saw in the graphic, we were coordinating and rendezvousing with Virgin Atlantic aircraft. They were operating an A350 as well, of course. And Air France and French V were also participating in these trials, what's neat is that Delta is a huge fan of collaborating with various partners. And in this particular case, there are a lot of partners. And like I said, for the trials, there are 4 different airlines. And I think, again, Laura can speak to this, but as far as putting it all together, the potential exists for multiple airlines to all share this and work together. And in this, like I said, we actually proved it by doing it with another airline when we did three trials with Virgin, actually paired with them.
Thanks, Kevin. I'm a keen cyclist and I do watch the Tour de France, and in the peloton, the lead cyclist will, move to the back and then they kind of cycle around. Is that going to happen here? Who would like to say that one? Kevin, perhaps?
Well, I mean, I can talk, obviously. Clearly, they wouldn't. And yeah, from a drafting perspective and all, in this particular case, I'm also a cyclist, so I get that. And but the idea in this particular case is once you've paired, you'll stay in the pair all the way across the Atlantic. For the initial concept would be going across the Atlantic and then splitting on the other side. So no, you would not ever change positions during a particular flight. However, on a subsequent flight, there may be other times, and again, this goes back into the pairing assistance tool, making a determination of which aircraft is better suited as the leader and which one's better suited as the follower on any given day in any given situation. So that's something that will be generated, as Laura spoke of a little bit, on a per case basis. But yeah, it's gonna vary. It's not gonna have one particular airline always the leader and one the follower, but I can see the potential for some randomization on that for sure.
Thank you, Kevin. And now a question for you, Andreas, from our audience, and this is about where the aircraft make landfall. So this is from Stephen. Thank you, Stephen. It's a great question. How will the traffic be integrated in the landfall domestic sectors?
Yeah, I mean, that's actually something which, to a certain degree, is still under development. I mean, right now, the concept, as we have proven it in Geese, especially the oceanic solution, does limit the wake energy retrieval concept to the ocean, right? But we are quite aware that there is an ambition to stretch those flights. I mean, if you look at the trajectories of the aircraft today, so many destinations, for example, going westbound to the US, would really benefit from them being together for a longer amount of time. So, like I said, I mean, currently they'd have to split up and then just re-enter as currently with aircraft do, but in the longer time, and that is actually going to be subject of the next project that we're going to do together, Geese 2. We are going to establish the concept of operation where these can be handed over and then dealt with by I want to say a little bit more complex and different continental airspaces, also as a wake energy retrieval pair. So I'm really excited to looking forward to that work, to extending the benefits. And in fact, we are very closely aligned there, for example, with NAV Canada already in Geese 2. So yeah, there's a great future ahead for this concept.
Excellent. Thank you, Andreas. We've got quite a few questions coming in now from our audience, and Sticking to the kind of, I guess, the in-flight aspects, we've had a question from Eric at Delta. So one of your colleagues, Kevin, but I think I'm going to direct this one to Laura. Let's see how we go. So Laura, is turbulence going to be an issue while intentionally staying within an aircraft's wake vortex, or can a smooth ride be anticipated?
Good question. So these 1.2 nautical miles I mentioned before is the right compromise, let's say, between the high saving. So if you are closer, you save more, of course, and yeah, they need to keep the comfort and the flight smooth. So when we did in Airbus the flight test in 2021, people on board at this distance said it was not. Yes, not really, you could not realize you were on the vortex actually. So the vortex after these 1.2 nautical miles is already smooth enough to allow the saving anyway, but yeah, without any shaking flight.
That's a nice question. Thank you, Laura. Sticking with you perhaps just for a moment, we've had another question from Ewan. Is it only limited to aircraft pairs?
So the physics works with more than this. So this is why birds are flying in V formations. But in terms of complexity and yeah, let's try for now for two. It is already challenging enough, let's say, and then we'll see.
Thank you, Laura. Well, they're flooding in now. So we've got another one. So let's stick with audience because I like these questions. Patrick from BA, any ideas on future DGPS application to allow IMC night formation join-ups, splits, and contingency procedures such as engine failure? Who would like to take that? Kevin, would you like to come in with this one?
I'm going to defer to Laura initially.
Laura, come in.
I can certainly add to that. Yeah. Okay.
So first of all, in any case, we will not rely on visual, let's say, rules and so on. So the pilot will not by hand follow the leader. Okay, so this concept works at night because the positioning between leader and follower is done automatically and based on signals received from the leader to the follower. However, so DGPS is differential GPS is yes, of course, is a position signal data which is more precise, more accurate with respect to classic GPS. But in any case, the idea, and we agreed on this with the other aircraft manufacturer on this, by the way, is that the positioning is really based on data transmission directly from leader to follower aircraft. So, of course, we can think on everything to correct these, to do some data fusion and so on, but the main input for the follower will be really coming from the aircraft in front.
Thank you, Laura. Sticking with the theme of the position of the aircraft, we've had another question from our audience from Philip. I think, Andreas, this is a question for you. So Philip is asking, with aircraft essentially on top of each other, how much of a problem is it for controllers to monitor for confliction?
Yeah, that's an excellent question. I mean, we did maybe get a little bit of an indication of how that looks like already from one of the images that we showed earlier, you know, where the aircraft had met up and were at a lateral distance of only 1.1 nautical miles. And for the controller, obviously, the indication that they're still separated is just basically the data block stating that, okay, they're still on different flight levels. Now, obviously, looking at the actual implementation of Geese, we'd have them on the same effective flight level. Now, what we are very much investigating is what kind of changes there would need to be for controllers to effectively realize that they are a pair. There's special rules which apply. And I mean, one thing to really emphasize here, we will still be operating on the current responsibilities that we have. So in the ocean, we have the standard separations that we're responsible for, the same for domestic. So in this special case of wake energy retrieval operations, the responsibility for the separation between those two aircraft will actually be transferred to the aircraft, and that is enabled by the technological solution that Airbus is building. There will be special phraseology to make that really clear who is responsible in this special state. So we don't have to imagine that between those two aircraft, the controller has to basically second to second make sure that they're not coming closer together or something like that. This is really thanks to these highly sophisticated systems that Airbus is developing right now. So the controller is looking with their tools at the separation towards third-party aircraft, and the wake energy retrieval pair will be, in some effect, considered together.
Thank you, Andreas. Sticking with this theme, we've had the questions are really coming in fast today. We've had a kind of linked question, I guess, from Edmund. Edmund's asking, given that the pairing tool is from Airbus, does this exclude other aircraft types from participating? Laura, I guess this is one that you might want to take.
Yeah, not at all. So it's true that the prototype of this tool was developed by Airbus because, of course, we need to have it to test these operations and so on. So it is really an enabler. So we decided to invest on prototyping the technology to demonstrate its feasibility and yes, to test it in real life thanks to the flight trials. But this doesn't mean that this tool, once it will be really in service operational, will exclude some aircraft. So the idea is that the benefit is really exponentially increasing if you have more aircraft. So this is why we have also Boeing by the way in the consortium. So we are working with them also in some standardization groups to align and to have some interoperability.
Superb. Love that level of collaboration. It's a huge project. Moving to perhaps the benefits then. A question from Ivan. Is this free energy for the follower aircraft, or does the lead aircraft use any incremental energy? I know how that one feels when you're on a bike, but Kevin, is this one that you can take?
Yeah, I mean, and again, I think Laura can also speak to this more from the technical and research and development standpoint, but the follower aircraft, as you said, using the bike reference, the person drafting or the follower is going to get the benefit. The lead aircraft, it's not creating any additional fuel usage or anything with the lead aircraft. They're doing what they normally do. And as the follower, that is where the fuel and what we're also interested in is the carbon emission savings as a direct result of the fuel savings is obtained. As far as, Laura, I don't know. I mean, the lead aircraft right at this point, there really is no difference for the lead aircraft. Is that correct?
Yeah, correct. So the lead aircraft will fly as if he was alone. The only small adjustment that could be needed to fly together is to change a little bit the step climbs. So this can change a little bit the fuel consumption flying together instead of flying solo, but it is really negligible, let's say, compared to the benefit of the pair together. Another point is to keep in mind is that the follower will, of course, need to change his trajectory, his routing to meet the leader. So this can, of course, also increase a little bit the length of the flight and then lead to some increase in fuel consumption in this rerouting phase. And this is why there is also this pairing assistance tool, which is taking into account all these parameters and proposing pairs which are not only feasible, but which are saving net fuel saving, also considering this rerouting. So it is not something you can do by hand like this. So this is why we need a tool for this.
So the tool essentially does a kind of full route-based calculation then, so you get, wow. Excellent solution. I like it. So,
Russell, can I add on to that just real quick? Just to add on to that, we were talking about planning a while back, and this is the perfect opportunity to really punctuate that, which is in that assessment phase, that's what the dispatchers are looking at is, would a trajectory change? How would that impact our fuel on arrival? And then we also have that last step to look at it in the flight deck and do an assessment and see if we agree. And I wanted to also add on to what Laura was saying about the level changes, because these are all conversations that we're having, which is one aircraft on a shorter ultimate route may be carrying less fuel or have less weight. And we may not necessarily be able to change levels at the same time. So that's something that's a consideration that we all talk about and is looked at to determine, is this feasible? Does it make sense on this particular flight? And will continue to be part of the assessment and in the development of this as we move on.
Thank you, Kevin. Andreas, you spoke a little bit about the second phase of the project earlier. I wonder if you could tell us a little bit more about what the next steps for the project are likely to be.
Absolutely. So, as I mentioned earlier, a thing that we really want to do is extend those operations. I mean, right now we do have a reasonably mature solution for oceanic airspace, which also has looked into non-nominal and emergency scenarios. And we do have one also which for the continental solutions has looked at, okay, how would it work in the busy and complicated airspaces of continental Europe, where you have many different sectors and flight information regions which need to all work together to make this happen. So in the next phase, what we'd really like to do is take the learnings from both of these projects and combine them together. And it's really fortunate that we have a greater continuity of people to work on with this. We actually have, I believe, also some more airlines joining this project, so we will be able to do more flight trials, more assessments of the pairing assistance tool. We will be able to do more sophisticated experiments also on the ground with our controllers to make sure that in all aspects, workload, safety, feasibility, we have covered all our bases, and we can then go on to the next steps of actually deploying this. That would be the ambition.
And when do you think we can expect to see routine formation flying over the Atlantic?
Well, I don't want to be putting words into Laura's mouth here, because I think one of the big parts here is your work, obviously, in developing the software, right, and certifying it, right? But I believe it was towards the early 2030s, correct?
Actually, the critical path is not on the aircraft side, it's on the regulation side and standardization timelines. So, of course, there are some separation standards to modify, some other industrial standards to modify. So this is the critical path. And in the aviation, unfortunately, this is not going as fast as we would like to go. So we are already, of course, working on this. So taking all the actions we can to push for these updates. But yes, I think yes, 10 years is a reasonable time frame, which is for aviation, it's a short time frame, I would say.
Thank you. We've got a nice question that's come in from Michael from Austrian Airlines. It's about weather avoidance. Would there be a split of the two aircraft in that instance where weather avoidance was necessary? I'm going to go with Kevin for this one, I think.
Yes, that's a concern of mine. Of course, it's a concern of every pilot's, is weather avoidance. And what I'll say is the initial idea with this is that the two aircraft will be able to communicate directly as well. And it will be kind of a consensus, and typically with safety in mind as the most important thing. The weather deviation will be agreed upon, and the lead aircraft will deviate, and the follower aircraft will also, it'll just follow along. And only in, there's obviously contingencies that will be developed that if there's the need to split, you would have the ability to split. But the intent from my understanding, and we believe me, we've had a lot of conversations about things, and this goes back to Patrick also asking about contingencies, is all contingencies are being considered when we do our safety assessments, both for on an individual flight basis, but also on the bigger scope of the project and what would we do if. And in this particular case with weather avoidance, the understanding is the lead aircraft will avoid the weather and the follow aircraft will follow along and also avoid the weather. So that's my best answer at this point. And yes, that is obviously it's something that's of high priority for the pilots.
Thanks, Kevin. And as we see this roll out, are you up for being one of the first pilots?
Absolutely. I was intent on being on these flight trials for that very reason. This whole project and kind of which speaks to the overall intent, and it's not just fuel savings. What's important is to recognize it's the translation of fuel savings to carbon emissions reductions, which is very consistent with Delta Airlines' commitment to sustainability. And so being involved in this project, the grand scope of the project as well as the technical aspects of the project is very rewarding, and I would absolutely be on the first aircraft to do it.
I think we've just signed you up. Thank you, Kevin. One for you, Andreas. So between NATS and NAV Canada, we manage the world's busiest oceanic airspace in the North Atlantic. Do you have a view on how we might see wake energy retrieval scaling up to the wider operation?
So it will be, of course, essential that we manage to unify the operations between continental and oceanic, and Geese Geese 2 will make some contributions to that. We have had already some preliminary discussions on how that might look like, but I think there's a good amount of work still to be done. I think in terms of ultimate scaling up, we are also looking forward to additional enablers coming online. So there are concepts in the wider air traffic control, air traffic management research sphere, which could really help us. For example, if it was more straightforward, more seamless to do those trajectory changes, because currently we are working with legacy systems, with electricity system interfacing that make things sometimes a little bit harder. So as these additional enablers come online, we can really look at scaling it all the way up to the ultimate ambition of having, as Laura mentioned earlier, 50% of aircraft, maybe more, doing this in the North Atlantic and maybe in other airspaces as well. That would be my answer right now.
Thank you, Andreas. And perhaps our final question from our audience for the show. This is from our colleague at NAV Canada. Wayne is asking, what would the vertical separation be at 1.2 nautical miles? I know we've touched on separations. Laura, you look like you're going to take this one.
Yeah, I can. So actually, the two aircraft will be at the same flight level. There are some, so there is a slight difference in altitude between the leader and the follower, only due to the fact that the follower will be positioned on the wake of the leader, and the leader wake is going down a little bit while going far away from the leader. So yes, there will be a small shift in altitude between leader and follower, but let's say the flight level at thousands of feet difference will be the same. Yeah.
Thank you very much, Laura. So into the final few minutes of the show, it always goes past very quickly. Kevin, you spoke briefly there, or you touched on the sustainability program at Delta. Would you like to tell us a little bit more about that and the other things that Delta are looking at beyond this program?
Sure. In 2022, Delta created the Sustainable Skies Lab, which is committed to really looking for and vetting and participating in various sustainability initiatives such as SAF, which is a big one, route optimization, just any possible ways, and also forward looking into new technologies, new aircraft design. And that's something that's been a commitment of Delta's for quite a while, and it just continues to get stronger and stronger. So being a part of this project has been very exciting, especially because we have a long-standing relationship with Airbus as the largest operator of Airbuses in the world. This has been such a highlight for us to be integrally involved in the development of this and committed to going into phase 2 with the project as well. But yeah, those are some of the programs that we're involved with, and many more. So there's a lot on the Delta website as far as under sustainability too, if anybody's interested in digging deeper into the specific projects.
Thank you very much, Kevin. Laura, Kevin signposted Airbus there. What else do you have on the drawing board?
Yeah, so of course, in terms of sustainability in aviation, we have two main axes, let's say, we can work on. So one is, of course, the operational side. So wake energy retrieval is really the operational side, the operational trigger we can use to leverage sustainability together with the so-called trajectory-based operation program and initiatives, which is really around the world pushed by the whole aviation world, so which is more or less what Andreas was also mentioning, to enable, let's say, an optimization of trajectories in a more dynamic way with respect to today. And then, of course, there is the side of the aircraft design. So, of course, we are always looking for new technologies in engines and aerodynamics and so on to make our aircraft the most performant one, of course.
Thank you, Laura. And Andreas, alongside Geese, what other big sustainability initiatives are on your radar?
So Geese is certainly taking up, I want to say, almost a majority of my time. But aside from that, I try to be involved as much as I possibly can on the field of non-CO2 impact of aviation. So most people know this as contrail mitigation. Now, this is, I think, a bit of an emerging field where the science hasn't entirely converged on how big the impact might be. But from the best results that we have so far, it is quite a significant percentage of the overall impact. And there are also indications that we might be able to, again, significantly reduce that if we were just to adjust our trajectories accordingly, let alone maybe look into the impact that new engine technologies, maybe also sustainable aviation fuel might be having, depending on how much available they are and when they are available. But I think it's a very interesting and important topic as well. And I really hope to be spending a lot of my time in the future on this one too.
Andreas, thank you very much. One final question then, just on the importance really of projects like Geese to the future of our industry. How do you view that? Kevin, would you like to go first?
I think it's absolutely crucial that all stakeholders are looking into ways. I mean, transportation is incredibly important. We know that. We also know that it has an impact. And, in the 30 plus years that I've been with the airline, I've seen a lot of enhancements. And, you can look at it and say fuel savings, and that's one of them from a cost standpoint. But the important thing is we're also looking at what that does in terms of carbon emissions and the impact on the planet. And that's, again, something I'm very proud of the Delta's commitment to and being a part of any projects. And so I think it's essential that we continue to look for those going forward.
Thank you, Kevin. Laura.
Yeah. So I think one of the strengths and beauties of these projects, so these but also other CESAR projects, is really the fact that we work all together, different stakeholders around aviation and ATM world, which is a very complex one. So many people doing different things, but at the end it is one flight seen from a very different point of view. So it is always surprising to see it to the end. Yes, really powerful to discuss with the people on the other side of the aircraft or the other side of on the ground, and so on, to align all together and learn from each other and find the best compromise for everyone.
Thank you, Laura. I think it's definitely fair to say that aviation is one of the industries in which collaboration is absolutely key. It's a really good point. And Andreas?
Well, I mean, I think Geese is really fascinating and important because I think it targets one of the operations in aviation which is notoriously hard, I think, to make even better than it is. I mean, the A350 and other wide-body aircraft are already incredibly efficient. And from my background in aerospace engineering, I know how hard it is to be pushing a single percentage increase sometimes for a component or for a system in terms of efficiency. And here we're having something which, for a relatively minor change on the airframe, can give us significant changes. I mean, Laura has outlined what we can do here, and I think that's hugely modifying and hugely important, considering how hard it is to decarbonize them.
Thank you, Andreas. Now we really are all out of time, so a massive thank you to Laura, to Kevin, to Andreas, and to you for watching. The show will be available on the NATS YouTube channel and as an audio podcast in all the usual places. Thank you all for watching. That was Altitude. Goodbye.